All right, let's try another chart question, slightly different. I'm given a reaction. I'm given the initial concentration of H2O in the container, and I'm asked for the final concentration of the H2 when I get to equilibrium. It's initial equilibrium, and I'm given K as this extremely small number. So I'm going to make my chart. Initial concentration, we said, of H2 is 0.1. I'm going to assume there's none of those in the container. This reaction is going to go right. So this is going to be plus 2x and plus x. And this is going to be minus 2x. And therefore, at equilibrium, I'm going to have x, 2x, and 0.1 minus 2x. I'm going to write my K equation for KEQ based on the reaction. I'm going to get its products over reactants into the coefficient 2, O2 to the 1, H2O to the 2. I'm going to plug in 7.3 times 10 to the minus 18 is equal to 2x squared times x all over 0.1 minus 2x, and that is squared. Now this is going to be a pig. I'm getting a cube term here, so I need to do something about this. And the key lies in is this thing is really small. So over here, we're going to do a little calculation. Initial concentration divided by KEQ. And that would be 0.1 divided by the 7.3 times 10 to the minus 18. If that is bigger than 1,000, x is small. And in this case, 0.1 divided by this extremely small number, minus 18, is definitely bigger than 1,000. So therefore, x is small. Now, when I look here, x is small. I'm not changing the top. I'm looking at this term right here. X is small. And I used the analogy before. If you have $1 million and you buy a chocolate bar for $1, how much money do you have? You have $1 million. So here, 0.1 minus a really, really small number is basically 0.1. So I'm going to write 0.1 minus 2x is pretty much equal to 0.1. So let's rewrite this equation. 7.3 times 10 to the minus 18 is going to be equal to, that's 4x cubed on the top, and on the bottom I'm going to have 0.1 squared. And I do some math, and I'm going to get that x is 2.6 times 10 to the minus 7. And now the question asked me for the concentration of H2 at equilibrium. The concentration of H2 is 2x. So therefore the concentration of H2 is equal to 2x, which is 2 times 2.6 times 10 to the minus 7, which is equal to 5.2 times 10 to the minus 7 molar. So here's how we do a question where K is really small. And you must show me this. In this question, this will be worth a mark. If you decide not to show me this little calculation, show me that this is bigger than 1,000, x is small, so this is true. Put it therefore there. You'll lose out on a mark. You must show me this, why you're making this approximation. Perfect.